In this lesson, we will cover Unit 1, Chapter 1, Sections 1.4 to 1.6, Solving for an Unknown Dimension. In this lesson, you will learn how to determine an unknown dimension for a right cone, right cylinder, right prism, right pyramid, or a sphere, given the object's surface area or volume, and the remaining dimensions. In Math 1201, you are not expected to rearrange formulas. You will need to first substitute the given information into the formula and then solve for the unknown dimension. In our first example, we are given the surface area of a softball, which is approximately 301.6 centimeters squared. You are required to find the diameter of the softball. Since we are talking about the surface area of a sphere, we're going to use the formula surface area equals 4 pi times r squared. We will first substitute the known dimension into the formula. For SA, you will substitute 301.6 centimeters squared. On the right-hand side, we will need to see what we can simplify in order to isolate the unknown dimension. We can first multiply 4 times pi. This will result in 12.6 r squared. Since we're trying to find the diameter, we have to find the radius first. R is the variable that you need to isolate. As a result, we will divide both sides by 12.6. 301.6 divided by 12.6 is equal to 23.9 and is equal to r squared. Now we just want to have the variable r. In order to do this, it is a setup similar to the Pythagorean theorem, where we're looking for the hypotenuse. We will take the square root of both sides. The square root of 23.9 is equal to 4.9. Since we want the diameter, we will have to multiply the radius by 2. 4.9 centimeters times 2 equals 9.8 centimeters. In our next example, a cylinder has a volume of 132.6 centimeters cubed and a height of 8.5 centimeters. Again, we are looking for the diameter of the cylinder. In this example, we are given two dimensions that are known, and we need to find one unknown dimension. The volume of a cylinder is equal to pi r squared h. You will substitute the total volume in for V and the height h, 8.5, in the equation. First, you can look at the right-hand side to see what you can simplify. Pi times 8.5 gives you 26.7. Again, we will need to isolate the variable r for radius. You will divide both sides by 26.7. Once you do this, you'll be left with 5.0, which equals r squared. In order to get r by itself, you will need to take the square root of both sides. The square root of 5.0 will result in 2.2. Since again you need the diameter, you will have to multiply the radius by 2. 2.2 centimeters times 2 equals 4.4 centimeters. As a result, the diameter of the cylinder is 4.4 centimeters. Our final example, we will look at the right cone. Its volume V and some dimensions are given. We will need to find the missing dimension. As can be seen from the diagram, we are given the radius of 1.7 meters and the total volume of 8.2 meters cubed. The missing dimension is the height. The formula for a right cone is equal to 1/3 times pi times r squared times h. Our first step, as in all the other examples, is to substitute the dimensions that are known. We will put 8.2 in for the volume and 1.7 in for our radius. On the right-hand side, we will multiply and simplify. 1/3 times pi times 1.7 squared will result in 3.0. Height, h, is the variable we need to isolate. Again, we will divide both sides by 3.0. 8.2 divided by 3.0 will result in 2.7. The height, which is a missing dimension, of our cone is equal to 2.7 meters. In summary, when you are trying to find an unknown dimension, first determine what information is given and what are you required to calculate. Next, substitute the given information into the formula. Lastly, solve for the unknown variable by using operations to isolate the unknown dimension.